All right, welcome back. So today we are going to be starting our third unit, or Unit C, where we're going to be looking at solutions. So these are going to correspond to chapters 5 and 6. And of course, if you do have a textbook or your digital textbook, chapter 5 we're just going to be looking at properties of solutions, where 6 we're going to focus on acids and bases. So let's look at our Part 1. So we're going to be looking at solutions and mixtures. So this is more or less kind of some definitions, and we're going to be using our periodic table as well, and really just try to understand what solutions are, what's in them, and everything like that. So first of all, I have to look at what is a solution. Now, the keyword here is that, first of all, it's going to be a homogeneous mixture. So just remember, homogeneous means that it looks like it's one thing. So like if something is dissolved in water, of course, it's going to look like water. So it has a uniform composition and different components that's making it up, right? So the components that's making up the mixture are not visible, hence a homogeneous mixture. Solutions are comprised of at least one solute and one solvent. Now we can get in more solutes, but generally it's just one solvent. So the solute is the substance that is dissolved, and the solvent, the substance that is used to dissolve something. It's in the greatest quantity. Now, for the most part, we're going to be dealing with a lot of solutions in water. Now, if we are using water, you're going to see the word aqueous solution showing up here. So this is a solution that has water as the solvent. Now, you are going to notice that aqueous is going to show up a lot, and we use the little symbol AQ, right? So for example, if we have sodium chloride or just salt that's in water, right? So this would be a aqueous salt solution. Right, so this little AQ indicates that water is present or it's dissolved in water. Now, of course, because we're going to be dealing with a lot of ionic compounds and stuff like that, the solubility of ionic compounds, including all bases, can be predicted using the solubility chart. So this is located on the back of your periodic table and looks something like this. So it's going to be in the top right-hand corner of your periodic table, and it'll say solubility of some common ionic compounds in water at 298.15 Kelvin. So we're going to go over how to use this now in a bit, but just so you know, we are going to be using this chart. So, of course, what is solubility? Well, solubility is just the amount of a solute that can be dissolved in any quantity of solvent. So the two things that you're going to notice is very soluble. So this is high solubility, and the state of matter is going to be AQ. Or not very soluble, or low solubility, in which it's going to stay as a solid. So that means if you put it in water, it does not break apart, it doesn't dissolve, it just stays as a solid. So how we're going to use our solubility chart to figure out if something will be considered aqueous or solid is, first we need to locate the anion, the negatively charged particle, at the top of our chart, right? So our first thing is we have a bunch of our anions up here, right, between hydroxide, sulfide, iodate, acetate, carbonate, phosphate, sulfite, sulfate. Most of the ones are up here. Now, next, we're going to decide on which row, the top or the bottom, the cation is located in. So if it's in the top row, so if the combination of anion and cation corresponds to the top row, we have high solubility, so it's going to be aqueous. And if it falls in the bottom row, it's going to be solid. Right, so what that means is we'll notice right here, so let's say, for example, carbonate is our anion, and we have sodium as a cation. Well, sodium falls in this top row, so it's going to be listed as very soluble. Whereas something like sulfate, if we had this, and it pairs up with something like strontium, notice that this combination is in the bottom row, so we're going to classify this as slightly soluble, or it's going to stay as a solid. So, of course, we are going to now practice some of these here. Now, some trends in our solubility chart. Now, all the following are very soluble. So if you have any group 1 ions, so group 1 is equal to the alkali metals. So that is our lithium, sodium, potassium, So if you have any of those, it's going to be very soluble, no matter what. Just fix that little N. And of course, all our compounds that have this, so ammonium, nitrate, chlorite, and chlorate. So those here will always be soluble as well. Now, if you see an element, low solubility, and it's going to maintain their own state of matter. All right, so like for example, mercury is a liquid, it's going to stay as mercury liquid. Copper is a solid, it stays as copper solid. All right, so what we have right here is basically just some examples of chemical formula and figure out if they're slightly soluble or insoluble. So I'm going to go through the first 2 or 3 with you, and then if you want to if you feel like you got enough and you want to pause the video and go through, please do that as well. So of course, first of all, when we had these here, mercury 2 chloride, you have to remember to apply drop and swap to figure out the correct chemical formula. Right, so mercury 2 means we have Hg2+, the chloride is Cl1-. So when we do our drop and swap, the 2 is going to go in front of the chlorine. The 1, well, we don't really need to write out 1, but we have our chemical of HgCl2. Now I'm going to leave this blank. Now we're going to have to figure out the combination, so by doing the drop swap, at least down here is where I get to see the anion charge and the mercury ion charge. So I go to the back of my periodic table, and first I find my anion, which is the chlorine right here. Now when we go down here, most of the things are very soluble, however there are a few exceptions. We have copper, silver, mercury 2+, mercury 2+, and lead 2+. So we have mercury 2 chloride, so this ion right here is going to make a slightly soluble or a solid notation. So we can write solid in here and write slightly soluble right here. Now, of course, I'll go over the other one with you as well, the sodium carbonate. So just remember, we do need to figure out the chemical formula, so we are going to apply the drop and swap because it is an ionic compound. So sodium, the ion charge is 1+, carbonate is CO3 2-. So our chemical formula after drop and swap is Na2CO3. Now I don't know the state of matter, so I'm going to keep it as blank right here. Now I'm going to go to the back of the periodic table and find out. So we find our anion first, so the negative charge ion. So that is going to be our carbonate, which is this one right here. So we have to figure out where the sodium is going to be. So we have only a few carbonates right here that are very soluble. We got hydrogen and sodium. So that means it's going to be very soluble, or we can write AQ. So that means we're going to go back, write AQ, and call it very soluble, just like that. So all the other ones you should be able to solve here on your own. So I'm going to put up the answers in about 3 seconds, so please pause the video and see if you can get them filled in. Right, and the answers are here. So we got our lead 2 fluoride is going to be slightly soluble, our strontium hydroxide very soluble, ammonium carbonate very soluble, iron 3 hydroxide slightly soluble, magnesium sulfate should be very soluble, and our lead 4 iodide is also very soluble. Now the whole point of kind of going through all these here and figuring out the solubility is we're trying to figure out if our solution is going to be conductive, so if it's going to be an electrolyte or a non-electrolyte. Now when we talk about the conductivity of solution is related to the type of compound dissolved. So an electrolyte is an aqueous solution that conducts electricity. So these here are going to be our highly soluble ionic compounds, so the ones that have AQ, and ionic hydroxide compounds, which is basically the same thing, the ones that we have AQ. Now our non-electrolytes, it's a solution that does not conduct electricity, so we're going to have our molecular compounds, our elements, because they don't dissolve, and of course our non-soluble ionic compounds as well. So all these here won't be able to conduct electricity. Only our highly soluble ionic compounds will. So what makes an electrolyte an electrolyte is we have something like this. So if we have dissolved ions, something like Sodium chloride, we can tell here we have all of our negatively charged and positively charged ions floating around in solution, and this is able to conduct electricity. Now, if we have a non-electrolyte, like molecular compounds like sugar, notice how there's no ions here. It's just a neutral molecule floating around in solution. So if it's neutral, it's not going to be able to conduct electricity. Now, I'm tossing the elements and non-soluble ionic compounds into this non-electrolyte as well because, first of all, they won't make solutions. So elements aren't going to dissolve. They're just going to stay as elements, so it won't conduct electricity. The water won't anyway, and same thing with our non-soluble ionic compounds. We're not releasing ions in solution. It's just not going to do anything. And we can test for conductivity by using something called a conductivity meter. Now, normally that's just a meter you stick inside a solution. If it flashes a certain color, like flashes a bright light, that'll indicate that there is electrolytes in solution, and if it doesn't flash, then there's no electrolytes in solution. Now, other tests that you've came across in the past as well, something litmus tests. Now remember, these tests is something is acidic, basic, or neutral. So acidic solutions, blue litmus paper turns red. So how to figure out if something is an acid, we have hydrogen on the left of the chemical formula, or you see the COOH. Now, basic solutions, right? Remember, these are all ionic hydroxide. So you see hydroxide in the chemical formula, something like that. All right, so sodium hydroxide, strontium hydroxide. If you see the hydroxide ion in here, then it's going to be considered a base. And these here turns our blue litmus paper red. And then, of course, neutral solutions, there's going to be no change in color of litmus paper. So these are all ionic compounds or molecular compounds. So as long as it doesn't fall into the acid or base category, then it's going to be neutral. Now, just remember, for a diagnostic test, for the acidity of solutions, test using blue or red litmus paper, which you've done in the past before. And this will help tell you if something is going to be acidic or basic. So for example, which of the following solutions, using the whole idea of conductivity and acid-base tests, we can start, using these diagnostic tests right here and start trying to figure out what's going to happen, or how can these diagnostic tests be determined by some of these solutions right here. So example, in which of the following solutions would test positive for conductivity. Now remember, for conductivity, we're looking for soluble ionic compounds. I'm not going to have enough space to write out compounds, so we're just looking for soluble ionic compounds. So right away, just by looking at some of our examples here, sodium carbonate I know is an ionic compound. I do need to check solubility, so sodium carbonate's a might. Methanol won't, because it's molecular. And molecular compounds will never test positive for conductivity. Same thing with sucrose. This won't test as well because this is molecular. So the only ones I really need to check is the sodium carbonate and the lead 2 iodide, because these are ionic. But I had to make sure that they're soluble, right? So go to the back of the periodic table. I'm going to check for sodium carbonate first, which, hey, look, it's already highlighted. I have the carbonate ion right here, and I have sodium, so it's going to be aqueous. So I know my sodium carbonate is aqueous, so that one will test positive for conductivity. Now my lead 2 iodide, I'm also going to have to check. So I'm just going to clear the markings I have right here. So I find my iodine ion right here, and I go down. Most are very soluble, that bodes well, but I have to check that lead 2 plus is not down here. Copper 1, silver, mercury 2, oops. Lead is right here, slightly soluble, so lead 2 iodide also won't, because it stays as a solid. So this is the only one right here. Our sodium carbonate is the only one that will test positive for conductivity. Now the next one is just looking at, for example 2, which of the following solutions predict the color of both the red and blue litmus tests after exposure to the solution. So if you want to try this one on your own, please do. But if you want to just kind of go through, I'm going to go through all these here as well. So first of all, we're going to have to classify our things here. So hydrogen chloride, we see hydrogen on the left, acid. So if it's an acid, that means red litmus paper will stay red. Blue litmus paper will also turn red. So that's what an acid will do. Our nitrogen dioxide is a molecular compound. So it's not an acid or a base. I don't see hydrogen in there. I don't see that COOH, and I don't see hydroxide, so it's just molecular. That means it will not change color of any litmus paper. So red stays red, and the blue will stay blue. As for the last one, the sodium hydroxide, we see OH minus, which makes this a base. That means the red will turn blue, and the blue will stay blue. So that's how we can tell based on just kind of figuring out what we should see based on the chemical formulas. All right, now for this right here, normally this was actually an activity that we done in class where I had unknown solutions for you A, B, C, and D, where you test with litmus, red litmus, blue litmus, and conductivity, and based on those, you're going to figure out if it's supposed to be calcium chloride, citric acid, glucose, or calcium hydroxide. Where you have calcium chloride ionic compound, citric acid an acid, glucose molecular compound, and calcium hydroxide, well, it being a base. So what we're going to do here instead is I'm going to give you the evidence, and then I'm going to want you to figure out based on these here what solution should be. Okay? So the evidence is, actually I'll just fill it in right now for you. And here are the results of our solution. So solution A, red litmus stays red, blue stays blue, and it is conductive. Solution B, we have red litmus paper stays red, blue litmus paper turns red, and it is conductive. C, we have red litmus paper stays red, blue litmus paper stays blue, and it is not conductive. And of course D, red litmus paper turned blue, blue litmus paper stayed blue, and it is conductive. So based on those results, which of the compounds are which? All right. So of course with these here, the answers we should have gotten. Sorry. The results we should have gotten, it's not going to be glucose for the first one. We should have gotten, sorry, this one should have been calcium chloride. We should have got citric acid. For C, we should get glucose. And finally, the last one, we should get calcium hydroxide. Based on the diagnostic tests, because A, where it's not acidic or basic but conductive, that means it's an ionic compound, so that's why we got calcium chloride. For B, obviously with blue litmus paper turning red as an acid, so that's why we got citric acid. In C, we have it's neutral, but it's not conductive, that's our molecular compound glucose. And then finally the last one, red litmus paper turning blue, that is a base, therefore calcium hydroxide. So that's how you kind of go through those results. Now, last but not least here, this is just where we're going to end as well. So this is just kind of extra practice with you guys as well, looking at different compounds and then predicting if it's going to be acid, or sorry, in this case here, it's just an electrolyte or a non-electrolyte. But the thing is, specifically the chemical formula with the state of matter, pay attention, but you should also really work on classifying them as well. So for example, oxygen by itself is just an element. So it's just O2. And state of matter for oxygen is a gas. And then, of course, elements fall in the non-electrolyte category, right? Because that's just based on what we've already learned on the previous page, that all elements are going to produce non-electrolytes. Now, as for your lead 2 chloride, so we know this is ionic. So the chemical formula is PbCl2. Now you are going to have to check the ionic compounds if it is soluble or not soluble. So we go back, we have our chloride and lead, is all the way down there, so slightly soluble, right? So that means it's going to stay as a solid and also non-electrolyte. Right, and then of course the charge on the cation matters a lot, because if you got lead 4 chloride, it's PbCl4. Now this one, if you check the solubility chart, notice here, this is lead 2, not lead 4. So lead 4 does not show up down here, so that means our Pb4 plus must be up here in the very soluble range, which means this is going to be AQ, which makes this an electrolyte. All right, so that's just the first few examples, and of course this goes all the way down to over on the next page until you get to sulfur, so we're up to S. So please work your way through these here, and as for the answers, check the Google Classroom. There should be the PDF already uploaded on Solutions Notes Answers Keys, so please go through and check those here. Then of course, if you have any questions about any of them, feel free to email me or just wait until we have our little Google Meet session where we can kind of hash out some of these. All right, so that is it for your first lesson in the Solutions unit. Just make sure to try your CYU books and work on a lot of these diagnostics things, and of course figuring out if something is electrolyte or non-electrolyte. And I'll see you guys for your next lesson when we're going to look at explaining solutions a little more. All right, see you guys later.